Okay, number 26. In 2010, the world population was about 6,870,000,000. The population of the United States was about 3 times 10 to the 8th. How many times larger is the world population than the U.S. population? So the first thing that I'm going to do is I am going to rewrite the world's population in scientific notation. So to write it in scientific notation, I need to put my decimal point between the 6 and the 7. Or no, that's not a 7, that's an 8. 6.87 times 10 to the, if I'm taking this 1, 2, 3, 4, 5, 6, 7, 8, 9th power. Now, what I'm going to do is I'm going to divide that by the U.S. population, 3 times 10 to the 8th power. The reason I'm going to do that is because how many times larger, I need to figure out 3 times 10 to the 8 times what will give me 6.87 billion. So when we divide in scientific notation, I'm first going to take my constants. So I am going to take 6.87 and I'm going to divide that by 3. 6.87 divided by 3, that's going to give me 2.29. Now, times 10, when we're dividing the same base, we subtract the exponents. 9 minus 8 gives me 1. So we really can, so this is not how we would say this. This is 2.29 times 10, or 22.9. When it, I would round this up here to 23 times. Number 27, there's approximately 4,500 species of mammals on the earth and 2.8 times 10 to the 4th species of fish. What is the difference in the number of species? Difference is going to tell me to subtract 4,500. I'm first going to write this in scientific notation. So 4,500 would be 4 times 10 to the 5th, or 10 to the 1, 2, 3rd power. So this is my mammals. And my fish here, 2.8 times 10 to the 4th. That's the bigger number, 2.8. I'm going to come over here. 2.8 times 10 to the 4th. Difference, I'm going to subtract 4.5 times 10 to the 3rd. When we subtract in scientific notation, the powers have to be the same. So I'm going to leave my 2.8 times 10 to the 4th power, but I'm going to change this is subtraction. I want to change this 4.5 times 10 to the 3rd to 10 to the 4th power. To do that, I need to move my decimal place one place to the left, 0.45. Now over here, let me just do a breakout of why I'm doing this. So 4.5, actually erase that, we already have that right here. We know that 4.5 times 10 to the 3rd is 4,500. So if I take, and I'm going to write this backwards just so that it matches here, 0.45 times 10 to the 4th, I'm going to take this decimal place and I am going to move it 4 places. So 1, 2, 3, 4. It puts my decimal place here. I have 2 zeros. Move that over so it's neater. And again, I have 4,500. That is why 4.5 times 10 to the 3rd is the same as 0.45 times 10 to the 4th. Now back to my problem over here. Now that the bases are the same, the powers of 10 are the same, sorry, I know that my answer is going to be in times 10 to the 4th power. So I need to take 2.8 and subtract 0.45. 2.8 minus 0.45 is going to give me, where'd my pen go? Sorry, I lost it for a second there. 2.35 times 10 to the fourth. That is your difference. All right. 28, we're getting there to the end, home stretch here. 6.8 times 10 to the fourth plus 9.24 times 10 to the fifth. We need to make sure our exponents are the same, so I am actually going to change my 6.89 times 10 to the fourth. This needs to get changed to 10 to the fifth power. So I am going to move that decimal place to the left one spot so that I can move it over five spaces now. So this is 0.689 times 10 to the fifth power. The reason why it's fifth power, if you think about, this was 10 to the fourth power, but the decimal place was here between the 6 and the 8. So I've moved it one place over, and then I have 4 more to go. So now that my decimal, or my powers of 10 are the same, 9.24 times 10 to the fifth, I know that my answer is going to be in the power of times 10 to the fifth. When I take 9.24 and I add 0.689 to that, I end up with 9.929. I just need to check, is this in scientific notation? Yes, it is. So that is my answer. Now when we multiply, the powers of 10 do not have to be the same. I'm just going, even though this is not in scientific notation right now, I'm going to go ahead and I am going to multiply my constants together. So 3.9 times 23 gives me 89.7. When we're multiplying, we're going to add the exponents here. So this is 89.7 times 10 to the 8th power. Now, this is not in scientific notation. To be in scientific notation, I need to move the decimal place one place to the left. So I'm going to get 8.97 times 10. Now that I've moved that decimal place one place to the left, I need to add a power on there. So my final answer is going to be 8.97 times 10 to the 9th power. Okay, circle the larger number. So to find the larger number, we need to probably expand these. 3 to the 5th to the 4th power, a power to a power. We're looking for 4 groups of 3 to the 5th. That would end up being 3 to the 20th. 5 times 4 is 20. Or 3 to the 10th, the larger number would be here. Number 31. Negative 2 to the 3rd to the negative 3rd power. So again, we're going to multiply. This is a power to a power, so we're going to multiply the exponents. The negative stays where it is. It's going to be 2 to the negative 9th power. To take care of the negative exponent, we're going to cross the line and change the sign. It's still going to be negative, so we have negative 1 over 2 to the 9th power. 1 over 2 to the 9th power is going to be negative 1 over 512. Just going to box that in there so we can see that answer. Now let's go through the next one here. So we have a negative 3 to the negative 2nd power, or to the negative 2nd power. Power to a power, we're going to multiply the exponents. So this is going to be a negative, negative 3 to the 4th power. Negative 2 times negative 2 is positive 4. So negative 3 to the 4th power is going to be negative 81. We need to figure out which one is larger. They're both negative. Which number is closer to 0 on the number line? The answer is going to be negative 1 over 5/12. So this is our answer. Last but not least, 3 to the 2nd times 2 to the 4th. Now, we do not have the same base right here, so there is nothing we can do to combine them, and that's very important. The only way we can use our exponent rules with multiplication is when the bases are the same. So we really just need to expand this here. 3 squared is 9. 2 to the 4th power is 16. 9 times 16 is going to give us 144. 9 squared is 81. The larger number, therefore, is 144. There you have it, my friends. Say bye, Charlie. Say bye, Charlie. Say have a good day. Oh, you're not looking. Right there. Look. Say bye. Say bye-bye.